All right, this will be the 7th grade review for Unit 6. This is the probability section, plus there's some review questions on here that we need to go over anyways. So taking a look at number 1, it says look at the cards and the coin below. Create a tree diagram and a list that shows all possible outcomes of drawing a card and then flipping a coin. Okay, so what I'm going to do is I'm going to create the tree diagram first. I'm going to do it in the order that it says it, just because I think it's going to help keep me straight. So what I'm going to do is I'm going to look at drawing the card first, then flipping the coin. So with my card, first I'm going to do is, here's going to be my draw. For my first draw, I can either draw a red card or I can draw a black card. Now I've got to talk about flipping the coin. Well, let's say I drew the red card. So now I'm going to do another draw. I can either get heads or I can get tails. Same thing on the black card. If I draw the black card and then flip the coin, I can either get heads or I can get tails. You don't always have to do the tree diagram every time. Sometimes it is easier just to list them out if you're pretty comfortable with it, but for me it gives me a nice visual. So if I do red card and then heads, that's one of my options. So I've got red card and heads. Then I could have done red card and tails. So red card, tails. On the next part, I could have done black card and then heads. So black card, heads. And finally, I could have done black card and then tails. So black card, tails. These are all of my options. Now, one thing I do want to mention is sometimes you guys are going to see it listed like this, where for red card and heads, they'll have it they'll have it listed like this. So red card and heads, like this one would have been red card and tails. So sometimes if you look, especially if you're looking at multiple choice, they're gonna list it out for you like that. And then obviously then black card heads, black card tails. Looking at number 2, Fred has a bag containing yellow, blue, red, or purple marbles. That's kind of weird. It should be and purple marbles. If the grammar is going to bug you there, change that up for an and. There are a total of 24 marbles in the bag. Kelsey randomly selects a marble from the bag and then puts it back. She repeats this process 15 times. If Kelsey selected a yellow marble 4 times, what is the most likely number of yellow marbles in the bag? So what we're dealing with on this problem is we are dealing with experimental probability. This process that she's done it 15 times, and she selected the yellow marble 4 times. What we are looking for is the yellow marble. So we're going to have 4 over 15, because that was the experimental probability of drawing the yellow each time. It happened 4 out of the 15 times. What it wants me to do is it wants me to guess how many marbles are in the bag. Well, in the bag, there is a total of 24 marbles. So that's why the 24 goes in the bottom. So now from here, I can solve for X, what I believe is going to be the total number of marbles in the bag. Because this is an experiment, it may not be exactly true, but because, we're just going to hope that it's pretty darn close. So from here, you can cross multiply and divide by the lonely guy. There's not really any way to scale up. So what I would do is I would do 4 times 24, and you would have 96. And then I would have to do that 96 divided by 15. Unfortunately, this isn't going to be a very nice number, but we're going to go with it for now. 15 can go into 96 times, so I've got 90 there. I've got my 6 left over, and because I'm feeling lazy, we're going to call this 6 and 6/15, which actually simplifies, but actually we're just going to change this to a decimal. This is going to be 6.4. Easy enough for right now. Which is kind of strange because there's not going to be 0.4 marbles in there. I could round this up saying that there are probably going to be 7. Your answers come test time aren't going to be that close, so you don't have to worry too much about it yet. All right, number 3. A friend of this guy I know's cousin's brother did a random survey of the students in the school and found that 70 out of 100 students plan to vote for Timmy for student council. Which is the best estimate of the total votes Timmy will receive if all 1,500 students of his school vote? So they give us our little ratio, proportion, or experimental probability right there. This guy, he's been doing surveys. He surveyed a total of 100 people and found that 70 people were going to vote for Timmy. Now, I'm going to set this up as a proportion where I know that there are 1,500 people in the school, and I want to know how many might vote for Timmy. before I go through any more of this, what I want to do is, to me, it's going to be, actually, I was going to say let's simplify this, but we can also, we can scale up. So I know that to get from 100 to 1500, I have to do that 15 times, because it's literally in the name, 15 hundreds. And that's a really terrible looking 15. So there we go, times 15. So I can do the same thing to get to X. I can do this times 15. And that will give me how many people I believe will vote for Timmy. So I'm going to cheat. I'm going to use a calculator. I'm going to do 70 times 15 in my calculator. And I get 1,050. This is how many people I think will vote for Timmy because of our experiment. Moving on to the next one. Number 4. Taylor has a fair number cube numbered 1 through 6. Now we've got 4 questions that are going to be related to this part right here. It says, is the probability of rolling an even number greater than its complement? So, meaning it's opposite of not rolling an even number. So 1 through 6, let's talk about the even numbers. We have 2, 4, and 6. That's 3 numbers out of 6. Well, those are the even ones. And for odd numbers, we have 1, 3, and 5. So that's another 3 numbers out of 6. These two are equal. This question was, is it greater than? So the answer right here is no, it is not greater than. The next question has a little bit of a grammar error. So get rid of that is there because it's a little extra. Is the probability of rolling a number less than 5 less than rolling a number greater than 5? So we're trying to compare the probabilities right now. So rolling a number that is less than 5, well, we've got 1, 2, 3, and 4. Those are our numbers less than 5 out of 6. Now we're going to compare that to rolling a number greater than 5. Well, the only number greater than 5 is 1. Is 6. And so there's one number out of 6 that is greater than 5. So the question now, I got to think about this because this is the first time I'm doing this. It wants to know if the probability is less of rolling a number less than 5, less than rolling, good Lord, too many lesses in here. Pretty much, I'm going to just put that because rolling a number less than 5 is more likely. So I don't think you guys have to do it quite like that on your test. The next part says, is the probability of rolling a number less than 5 greater than its complement? There's an extra is in there. So, probability of rolling a number less than 5, well, there's 1, 2, 3, 4, so that's 4 numbers out of 6. And the complement of not rolling a number less than 5, well, there are only 2 numbers that are not less than 5. We got 5 and 6, right? So that's 2 out of those 6 numbers. Well, the probability right here, honestly, I'm going to stick with these symbols because these questions aren't written really well. I guess I could blame the guy that did it. That would be me, so my bad on that. But just to try to answer it yes or no, it says, is the probability of rolling a number less than 5 greater than its complement? It is greater, so technically the answer here is yes. Final part on this number 4, which is just terribly written. Is the probability of rolling an odd number less than its complement? So let's talk about probability of rolling an odd number. Well, there are just as many even numbers as odd numbers. Odd numbers, because that's what's listed first, are 1, 3, and 5. So that's 3 out of 6. And is the probability less than its complement? Well, the complement is 3/6. Well, this is the only, they're equal again. So these are the same. So the answer is technically no, because it's not less than what we were talking about. All right, on to number 5. It says the deli created the following circle graph of types of bread customers preferred for their sandwiches. Estimate the percentages for each section. Okay, so here's what I do know. I do know that this whole thing is 100%. Now I got to figure out each section. I'm going to start with the pita bread because that's easy enough. To me, that looks like it's about 1/4 of the entire thing, which this would be 25%. The roll, well, the roll is kind of hard to guess. It's more than 1/4, so I'm going to go with like 1/3 or something like that, which is around 33%. I could even call it 30%, but those two, to me, are the easiest ones. So now here's what I've got to do. That bagel, that doesn't look like very much. Let's just guess that it's about 10% for the bagel, because that's not very much of that pie chart at all. I could probably have 10 more sections of bagel on there and be pretty close. And white bread and wheat bread look almost the same to me. So here's what I'm going to do. I'm going to add these numbers here. I'm going to add the 25, the 33, and the 10 together, and I'm going to subtract that number from 100. When I do that, I get a total of 68. Should have done that in red so it'll match my circles. And when I subtract these two, let me think what that's going to be. It's going to be about 32. So 32 for white bread and for wheat bread. So what I can really do is just do 32 divided by 2. And I can guess that each of these is going to be about 16% each. Is this exact? I have no idea. I've got some pretty specific numbers there, but only because I recognize some fractions. I think the easiest part for you guys to start out with is the pita bread, because that looks a lot like 25%. If you only had the roll as 30%, I would totally take that. It's just estimation for this part. All right, number 6. All right, how many times can Henry expect to roll a 5 if he rolls a fair number cube 240 times? Well, let's talk about rolling a 5. On a number cube or die or whatever else you want to call it, there's 1, 2, 3, 4, 5, and 6. Well, there's that 5 is going to be only one number out of 6. So 1 out of 6 is our probability of rolling a 5. And this guy's going to do it 240 times. So what I've got to do is I can do cross multiply, divide by the lonely guy, which is going to be the easiest way to get this, I think. Well, 1 times 240 is just 240. So now I've got to do 240 divided by 6. Well, 6 goes into 24, was that 4 times? 24. Got to do my subtraction, have a 0, and I got to fill in the gap there. So I would expect it to happen about 40 times. All right, backside with number 7. Will has a spinner with 6 equal sections numbered 1 through 6. If Will spins the spinner 100 times, how many times can he expect to spin a number less than 5? Well, so it's equal. It's just like rolling a number cube. So 1, 2, 3, 4, 5, and 6 are our total number of options. Numbers less than 5. Well, the only numbers less than 5 are 1, 2, and 3. And 4 because I'm being an idiot and I didn't write it in there. 1, 2, 3, 4, 5, 6. My bad on that. So I've got 4 numbers that I'm talking about. That's 4 numbers out of a total of 6 numbers. And we're going to spin this thing 100 times. And we got to guess about how many times our experiment would show. So what I'm going to do is I'm just going to do, again, another round of cross multiply. Divide by the lonely guy because these numbers are pretty simple. 4 times 100 is 400. And then we have to divide by our lonely guy of 6. Again, I'm cheating and I use a calculator, so this is going to come out to 66.6 repeating. So we're going to guess that he would probably roll about 67 times. Number 8. Janice rolls a fair number cube 60 times. She rolled the number 4 12 times. What is the experimental probability of rolling the number 4? Write your answer as a decimal. So let's talk about her experiment. She does it a total of 60 times, and she rolled that 4 12 times. So that 4 happened 12 times out of a total of 60 rolls. That's pretty much our answer there, but in order to do this, we need to divide it. We can do top in, goes in the little house, bottom out. But that looks like a pain, so I think what I'm going to do is I'm going to simplify first. I can absolutely do that, but I'm going to simplify. I know 12 goes into 12 one time. 12 goes into 60 5 times. That should be far simpler. So I'm going to put my 1 right there. I'm going to go ahead and make it a decimal spot. 5 goes on the outside of the house. Well, 5 can't go into 1, but 5 can go into 10 2 times. So our decimal is going to be 0.2. Number 9. Josephina lives on a farm with 3 sheep, 2 goats, 13 chickens, and 5 cows. She's going to randomly select an animal to take to the stock show. What is the probability of randomly selecting a cow or a goat? Before I even bother doing that, I want to know how many total animals we're talking about here. So here they are. We've got 3 sheep, 2 goats, so that's 5. 5, so I'm adding all of these right here. 5 and 13 is 18, plus 5 more would be 23. So we've got a total of 23 animals to pick from. And we want to know the probability of randomly selecting a cow or a goat. So now I've got to add my cows and my goats. So there's 2 goats, there's 5 cows, so we've got 7 out of 23. And that's about as simple as that's going to get. So our probability is just going to be 7 out of 23. On to number 10. Marcia gave the cashier $20 to pay for 3 pairs of socks. The cashier gave her $6.03 in change. Each pair of socks costs the same amount. What is the cost in dollars and cents for each pair of socks? So this is kind of an older problem. This is clearly not probability, but we're going to go with it anyway. So she gave the cashier $20, and she got $6.03 in change. So what I'm going to do is I'm going to subtract those two because I want to know how much she paid for the 3 pairs of socks. Gonna have to do some borrowing on this one. I'm going to cheat. Well, I was going to cheat a little bit on this one, but I feel like this is something you guys need to know. So that becomes a 10. Now it becomes a 9. That becomes a 10, and now it becomes a 9, and now I can subtract 10. So 10 minus 3 is going to be 7. 9 minus nothing is 9. 9 minus 6 is 3, and 1 just comes down. So paid $13.97 for 3 pairs of socks. Well, if I want to know how much each pair of socks is, I'm going to do $13.97, and I'm going to divide that by 3 for my 3 pairs of socks. And this will tell me how much each pair of socks comes out for. So 3 can go into 13. Let me change color so it doesn't blend together. Goes into it 4 times. That's 12. That's 1. Bring down the 9. 3 can go into 19 6 times. That's 18. Another 1. 7. And then 3 can go into 17 about 5 times. This is gonna keep going on. So it comes out to about $4.65 for each pair of socks. Number 11 says find the solution to inequality. This is old news, guys, but it's been a little while, and I know that these are rough. My recommendation is, for starters, right here, I would write that as x over 2. I think that's going to make a lot more sense to you in the long run. So what I'm going to do is I'm going to rewrite this problem. I'm going to write this as x over 2 minus 3 less than or equal to negative 1. First step is you always want to get everything away from the variable. You want that x cold and alone. I'm going to draw my line down there. I'm going to add 3 on both sides. When I add 3, that goes away. On the left side, I'm left with x over 2 less than or equal to negative 1 plus 3 is 2. Now my final step is I got to get that x by itself. So that's division. This part right here is division. So I'm going to multiply both sides by 2 to undo that. And now I'm left with x less than or equal to 4. If you have questions on that part, guys, you got to come ask me because I want to help you out with those. Thankfully, our final problem says Jasmine has enlarged a drawing that she made in art class. What is the value of x? Okay, a couple ways to do this. We've talked about these before. You can set this up as, well, actually, let me go ahead and highlight similar sides. That 10 is going to be related to that x. That 15 is going to be related to 60. So I can set this up as, and again, this will be figure 1, figure 2. So what I'm going to do is I'm going to set this up as a proportion. I want to solve for x, so I'm going to put x there. X is related to 10. That 10 is related to the 15. And that 15 is related to the 60. If you're good with that, awesome. But one thing that I think you guys really need to be able to do is just think about what you multiply times 15 to get to 60. Well, I can do 15 times 4 to get to 60, which means I can do the same thing right here. I can do 10 times 4 to get to my x, which ends up being 40. The same thing would happen here if I wanted to do this. I could cross multiply both of these. I could divide by the lonely guy. That'd be 600 divided by 15, and this would also come out to 4. Both are completely acceptable options. You just got to do whichever one you are more comfortable with. If you're still struggling on this stuff, guys, come bug me in the mornings, and I will help you out.